Good afternoon, guys. I realize I am second to last in between you and drinks and a commute home, or a drink and a commute home. My chat is going to be about my journey through graphs and how, as a data guy, I've been in data management for pretty much my entire career, how we have applied graphs to what we do. So, outline what I do and used to do. Early graph work, and then on into what we are doing today and how we are looking to expand our usage and applications of graphs, and really the linked and connected data to our business problems. So a little bit about me. I'm currently at a company called LPL Financial. It is the largest independent broker-dealer in the US, and I lead their enterprise data and information services group, as well as their advisor commissions and compensation platform. In the past, I was a product manager for enterprise data at Bloomberg, group data services design authority at UBS, data distribution at UBS and Morgan Stanley, and I used to work a lot. That was when I was a geek on a time series database. I think I'm still a geek, but that's okay. So, how I sort of got into graphs without really knowing that I was into graphs. We were focused on market data, and market data is something that has to be counted. All these vendors, all the exchanges and data vendors realized they could make money by going at hits rather than selling licenses and rights to organizations for using that data in various contexts. So we needed to build a system that could essentially count hits for different types of market data as it was presented to users. And SOA and SOAP were coming out at that time. Convergence and Confluence built a little system to just serve up market data out to Morgan Stanley's external customers. Turned out that was a pretty good thing, even for internal applications, because what we wound up solving was a lot of the complexity of connecting to different disparate databases and data systems and data sources to get the data that you need to do the processing that you do. And this thing grew. This thing grew in about 7 years to encompass most of data access, pull data access, at Morgan Stanley, comprising all of the enterprise data domains that they had. What made us successful at doing this was the speed at which we could incorporate new data sources, as well as the ability to sort of take in process flows and bring on usage, data processing flows and bring on usage. We could just do it rapidly, faster than anyone else. And the key problem that we started to solve from an infrastructure and technology perspective was we were starting to consolidate access patterns. So we could focus on challenges as access increased, demand increased from a central place instead of having to deal with hundreds of thousands of usages and users. And this is, as we grew complex, the early inkling of Graph-iness started. So we were getting complex, 70-odd systems, thousands of tables, hundreds of thousands of attributes that had to be matched and merged to use cases, to people, and so on. And what we had been doing was essentially our superpower, our G-star, right? Superman gets his energy from the yellow sun, his powers. So our G-star was that we were configuration driven. We made a conscious decision to not have logic in code or to minimize logic in code, but to actually pull it out from the system into configuration. Our configuration took two forms: tree structures, XML structures, to essentially encapsulate queries and state changes for a data processing step, and then a truth table or set of truth tables to route the usage to the specific set of specific data processing flow or set of sources that would serve up that user's need. But it was getting hard to manage this. And what we needed was to not have pre-configured flows and route to them, but to determine the flow dynamically. And what we came up with this, and I was quickly skimming through the graph algorithms database book that we just got, I was essentially doing a lot of pathfinding. And so we came up with this HNF algorithm, stands for Hare and Firkin, which is a great pub in Toronto, which is where we came up with the algorithm after lots of beer. And essentially, we said, look, if someone wants an output, based on an input that they've provided, if they want an output, we have to create a model that we can sort of say, how do you find the path from what data fits them, what data is available, and what data they are permissioned to. And that flow, or those flows that come about, then we can order and execute to deliver that result. But we didn't do this as graph. We didn't even think of it in terms of nodes and edges and so on. We just sort of said, yes, this is our beer-induced, beer-fueled algorithm called HNF. I left Morgan Stanley, I joined UBS, and essentially I was hired to do the same thing that I had done at Morgan Stanley at UBS, but bigger, right? So 3 main desires at UBS. One was that moved just beyond pull to push. I'm sorry, I have that wrong in my presentation. I wrote it this morning. But really start to be able to push data as well, right? So you start to get real-time subscribers. You almost get a data video player that people could consume. A big challenge at Morgan was where workloads for write and other transactional applications were sitting with the read workloads that we were imposing on it. They wanted to separate that capacity. So which means I had to load data, or I had to create a read layer, read masters as I call them, to be able to serve up these usage patterns, right? And then we needed to be able to support customizable, configurable capacity, right? Capabilities and capacities for users. If you're a trading application, your performance SLAs, the structure and the surface of data that you need is small, but your performance SLAs are incredibly vast, right? Versus a credit risk application, which needs a very broad surface of data, shaped in a specific way so that they can very rapidly compute through it, but they're going through reams and reams of information. And instead of saying there's a system or an algorithm or a capability that one thing can serve both needs, we wanted to say we have a centrality of read data, which now we can shape into different structures, into patterns, into processes to serve up different types of usages. So, great, rinse and repeat. I've tried this before. Let's go configuration-based, but this data model got really, really complex. We essentially got stuck. We were trying to do a relational model with some, tree-type structures to try and manage it, but we really wanted it to be relational. XML is hard to query. It's hard to find people who know XQuery and XPaths and things of that nature. And we got stuck. We really, really struggled to coordinate. This was a large team, about 40-odd individuals, really smart individuals who were trying to work on this, and we just constantly got stuck because we kept on having to refine the model. And I lucked out. I went to a QCon in New York, and I went to a Neo4j presentation, and the pieces just sort of fell into place. I was like, wait a minute, what we're really trying to model is a graph, and that's what we need to do. And essentially, that's what we wound up doing. We built something called the Integrated Data Platform at UBS, IDP. And instead of having to deal with abstract metadata models, we could actually just go into Neo4j, create for this problem area that we were focused on in terms of data access, what we needed without regards to anybody else. It could be duplicated, it could be, didn't matter what shape, what relationships you created, but you could work on the problem piece at a time, in isolation, in the same graph. Underneath, there was a team that was essentially understanding and taking those use cases and building out a graph model that served them all. So essentially, we could improve our scale of delivery of the metadata model because we didn't have to work with each other. That's an odd thing to say, but that really unlocked the project because the graph, in fact, Neo4j made it so easy for people to start to create relationships. We had simple community rules. You can't mess with somebody else's nodes. You can use them, but you can't mess with them. You can't mess with anybody else's properties. That was it. And that the ground was open. And there was a team in between, essentially, that was essentially sweeping up all these things that people were doing. Valid use case, here's a more centralized, better model and approach. which could move at a very different speed than these satellite teams. So, and I like the term, I think Dr. Negro used this today, right? The brain. We called it the brain of the system. So we didn't have code that knew what to do. We had code that knew to ask the brain what it needed to do right now. And essentially, in terms of loading our data, shaping it, preparing it, validating it, and serving it up, this metadata model served as the linchpin, as the center point. Having this data in there also created a lot of side benefits. And this is something that you want to take from the graph model and graph databases, that as you load in data and you build connections, a lot of other use cases, almost for free, would emerge. I'm going to talk about that. But we essentially laid the groundwork for UBS's efforts in BCBS 239, which is a data lineage regulation that is very broadly applied to financial industry today, and GDPR, which is Europe-driven privacy, and we'll talk more about that in a bit as well, because I left just as these things got going. Okay, so as sort of a side note, but I wanted to make this connection. I went to Bloomberg. I thought, I should be working for the business, data guy, make money out of data and so on, be on that side. And at Bloomberg, I focused a lot on linked data, so JSON LD. I think there was a question earlier today, how do you merge graphs or translate graphs and so on. A lot of the linked data, internet, protocol and semantic RDF triples and all that is wholly applicable to this stuff. Neo4j just does it better. All right, it's actually because you have properties, because you have directed graph, you actually have a much cleaner mechanism to do so. As well, you're not just dealing at the concept, but you're talking about instances now, right? And from REST was where the underpinnings of a knowledge graph started, because I saw to learn REST, I had to really deeply read all of the RFCs that make up the HTTP protocol, start to put all of those pieces together, and I was like, this is a graph model, right? This is this can be represented instead of the dry text that they have so much better in a graph. Okay, so product management was not fun. I like research, but I love building things. I'm an engineer at heart. So I joined LPL, and my focus at LPL was broader, right? So I was hired as the head of data. I was dealing with strategic plays and business problems, so less at the system level, more as how to apply systems and designs to what we want to do, what we need to do. And I was hired because there were deep challenges at LPL, Disparate data systems. It was a very project-oriented company. We are moving to a product orientation, but every single project built their own data. So you had a lot of same, similar, but different data. And there was no agreed business owner, definitions of data, et cetera. And because of this, any new system that's coming up did not know what data to trust. So they said, you know what, just to get into our timing, we'll build our own. And feedback loop to making the problem worse and worse and worse. What LPL did not want to do was embark on a multi-year, multi-millions, tens of millions of dollars program to say, okay, we've improved our data, or we've tried to improve our data, and we've only gotten so far. And we sort of coined this new concept of agile strategy, right? So agile strategy is, look, we have a vision, and we think that's the right vision, but instead of investing masses of effort and resources against it, dollars against it, let's go in pieces. Let's pick battles that we can win. Let's pick battles that are important and crucial to us right now. Do them in part or in under the umbrella of our strategic vision and desire and goals, but just focus on those things. So one of our key problems, and just a little bit about LPL, just to explain the problem context here. We are a service provider to independent financial advisors. We don't trade our own book, so we don't compete against our investors or our clients in the markets. What we offer is access to markets for trading and custody, as well as a technology and compliance platform. As such, we're a business to consumer, and the service center is our most critical function from an advisor's perspective. So the foundation of our technology and our platform, our accessibility and so on, but how most people engage with us are through our technology portals and our service layer. And heavily regulated, especially in the US as a financial enterprise, we had a challenge with fraud alerts, right? So in fraud, you essentially start to define rules. Like if you're going to sit in front of a regulator and say, hey, here's my control scenarios, there's a series of rules that you've defined that are going through data, transactions that have occurred, events that have occurred, and identifying, hey, there might be something here, somebody should look. And as we were doing this, we realized we were generating a lot of alerts for the same person or for the same household. And with each alert, we have to follow up. That is the requirement. So we were calling the same person or having the advisor call the same person multiple times for potentially similar things. Instead of doing that, we said, okay, can we do this better? Can we sort of invert our thinking and say, let the alerts come as they may, but let's group them by person, by household. And to do that, we needed to create essentially a data management layer that allowed us to take our account data and essentially start to elementize it out into nodes and edges, right? So I have an account, here is my account node, account attributes off of that. It has a relationship of various types. It could be beneficiary, it could be the primary account holder, it could be a secondary account holder, it could be the advisor, to a person. Those persons have geographical attributes, they have other identifying attributes, and now we can run algorithms, essentially community algorithms, to say, this looks like a household. Feed our alert stream through that, so that from a contact requirement, we're actually reducing that scope down from hundreds to a few handful per advisor. And this essentially saves a lot of time, all right? But its key power was, another key power was that it allowed our business users to start visualizing the data and seeing the relationships that they across the entirety of their data set. Instance versus concepts is a powerful shift that users have to make. They sort of think of data as rows in a spreadsheet, but if they can navigate concepts and instances at the same time, I think they become truly empowered. We got our present surprises off of this. And again, I'm just going off the book because it gave words to what we saw. We started to see that there were a lot of nodes that had high connectedness. And that was not a good thing, because that implied data entry issues or data quality issues, right? You cannot have a household with 5,000 members in it. Something is wrong in the data. And we started to look for those things, feed back up to the systems that were the systems of records and sources for that truth. So essentially the system that was trying to just be at the edges, trying to help group things, actually started to give a feedback loop out to upstream systems to improve data quality. And more of that is being done, looking at this data. Again, because of the connections, because of the graph algorithms, we're able to find these more easily and prevent them, remediate them, but also start to look to prevent them from happening. A lot of this is about training. People were just, if they didn't know the information, they were just plugging in anything. And as habit, I mean, there was a lot of goodness in terms of identifying where the issues were coming from. I think our bigger benefit, and this is going back to a question earlier about versioning, was because investigation takes a long time. we needed to maintain state, right? We needed to say, hey, Joe had an account. That account, was transferred to a different account or was consolidated with other accounts. Even though some alert occurred at that account, we needed to know that, albeit the account today no longer existed. So we used a very simple mechanism of time nodes, and to, I think, Courtney's point earlier, timestamps, to and from timestamps on the relationships to maintain this history. The secondary benefit of this really came to our service folks who, when they received a call, hey, blah, 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 this, and it's now this, and they had a very clean path to sort of say, hey, what happened? Again, from an ancillary system, not part of the system of record, but because of the visualization, because of the simpler querying, they were actually able to see what happened over time, and our calls started to get better. Those types of calls, not all of them. Okay, we'll move on to the next one. And then, so it comes full circle in that at UBS, I was much more focused on metadata and sort of my world, inwardly looking, right? I'm going to describe how I see data sources and semantic models and da-da-da-da-da. And then initially at LPL, we went, okay, now we're going to apply this to instance data and start to get uses coming out of this. But earlier, I guess last year, California passed a Privacy Act. And this act has essentially 4 components to it. As a California consumer, you are allowed to ask a company, what data do you hold on me? Right? What type of data do you collect, essentially? You're allowed to ask the company to provide that information to you in a portable format. You're allowed to ask that company to opt out yourself from sharing that data or selling that data to others, and you're allowed to ask the company to delete your information, if allowed by state and federal regulations. There's a lot of exceptions in that place. So what does this mean? Well, we need a place where we have all persons. We've almost got it. We've got all of our accounts, all of our investors, we've got all of our advisors. We have to add a few more populations in, employees, sponsors, partners. But we have a place already, because of fraud work, for holding our persons. Now we need to know, what data do we hold on people? Going back to the old UBS days, so we need to bring in our physical data inventories. We need to start to assign roles to data and applying that to the instance attributes. Do we hold this information or not? Essentially, the bulk of the work was creating the persons database and using our old muscle, my old muscle of metadata, combine them together, and all 4 of those questions can be answered. Hi, I'm Kim. What data do you have on me? Simple pathfinding query against the graph. Can you give me my data? We don't hold all of the data in there, but we hold the index to go to all of the places. So build services that find the paths of where the data exists, grab it, shape it, ship it, right? I want to opt out. Simple tweak on the graph. When we share data, you just check, am I allowed to share this person or this row or these rows? And then deletion, same index, let's just go anonymize the data, throw away the key, the identifying data, throw away the key, off we go. And really the system sort of morphed how we were very scared about this law, not a regulation, and how do we implement it in time to just making it actually very simple and easy. And then finally, what are we doing now? So Dr. Negro spoke earlier today. I met him in Charlotte quite some time ago, earlier this year. Seems like quite some time ago, but sometime around April or May this year. We are very keen on knowledge graphs, right? We want to take what we have as user guides. So we have a lot of text lying around that we surface up to our users. And as help guides, as cookbooks, as how-tos and whatnot. We have built a skills matrix. We have built a vocabulary, our business has rather, I shouldn't say we. We want to take all of that, pull that together, that corpus, into a knowledge graph that we can then start to curate and build out and build out. Why do we want to do this? So as I said, service is a big part of it. We want to avoid service calls, because if you don't have to call us, if you found the information on your own, you're happier, we're happier. We spent less money, you got your work done faster, you're happy, right? So we really want to make a better search, essentially. That is a critical aspect of making our information, our knowledge accessible to our users. And Solar, Lucene, all these things just don't do a good job. They're not good enough, right? It's needs a lot of work to curate them and build out those data models. And we think the knowledge graph is the right way. We also want to allow our users to interact with chatbots. Our users tend to be doing work at all times, all hours of the day. It's a diverse population, 17,000 odd financial advisors. It's a very diverse population spread throughout the country. So we want them, again, to be able to use chatbots, other mechanisms, texting, so it's also a chatbot essentially, right? But allow them to actually interact with our knowledge graph and get their questions answered, their issues hopefully resolved faster and better. As we add in employee skills and employee availability, busyness, and there's a lot of challenging engineering challenges here that we're trying to solve, we can actually start to do intelligent call routing, right? So you call in, as you describe your problem in an IVR, we recognize keywords, try to make a guess at what you're calling about, or you specifically, through a sort of a phone menu or some such, tell us what you're calling about, and we'll route you to the right person the first time around without the phone transfer game that a lot of service companies play, and get you to the right person to handle the complexity of your world. There's another effort that we'd like to kick off later on next year. And I think Dr. Negro also talks about this. This is our personalized intent Markovs, right? So essentially, profiling our users, and our advisors, our home office users, and trying to understand what they are doing, what they have been doing recently, to again give them better contextual information. And I think there's a lot more use cases beyond this, but that's what I am thinking about these days. And that's my presentation. I'm open for questions.